Hello, everyone. This is Judy Murray with Upstream. Welcome to today's webcast, IIoT 4.0 for the oil field, a new norm, sponsored by Rajant. With the help of our expert presenter, Rivero, Director for Oil and Gas at Rajant, we're going to learn how to make smarter smart fields using IIoT 4.0. But before I hand things over to Al, I would like to tell you a little bit about Rajant. Rajant was founded in October 2001 and is headquartered in Pennsylvania. It's an exclusive provider of peer-to-peer private kinetic mesh networks consisting of breadcrumb wireless nodes powered by its patented InstaMesh networking software. Rajant has hundreds of installations to its credit for the military and across industry sectors including mining, oil and gas, agriculture, transportation, shipping, petrochemical, and manufacturing, in addition to municipalities and federal and state governments. Combined, this constitutes more than 40,000 network nodes operating in a variety of private networks. Now, I know you're anxious for Al to begin, so I'll just share a couple of things about participating in today's webinar before he gets started. First, you can submit questions at any time by clicking on the Ask the Question area, typing your question, and clicking the Submit button. After the presentation, Al will answer as many questions as time allows. Any question that can't be answered within the time constraints of the webinar will be answered by email. Now, just a couple of housekeeping notes. If you're running pop-up blocking software, please disable it to view this webcast. And we recommend that you close all other applications for the best system performance. For your convenience, this presentation will be available on demand within 24 hours of today's live event. And a reminder email will be sent to all registrants with a link to the archive, and the webinar will be accessible from the homepage at upstreamonline.com. Now, it gives me great pleasure to turn the webcast over to Al.
Good morning. Again, my name is Rivero, and what I'd like to do is kind of go through and do a little bit of level setting before we get started with the presentation. One of the things that I've come across over the last couple of years in talking about industrial IoT and IoT 4.0 or IoT of the future is kind of, if you talk to 40 different people, you tend to get 40 different answers. So my view of the world and what we're going to cover today is really about the industrial Internet of Things, the interconnected sensors, and all the objects associated with them that enable publishing and accessing information both in control and non-control environments. Kind of the use of a cyber physical environment in the value chain to help optimize our operation and make sure that whatever we're doing in the control can be expanded and allowed to work together in a better environment. So with that in mind, I wanted to put that up front in the beginning, because if you're expecting to hear other things, you may not hear that. The other thing, for some reason, I thought everybody was mute and there's some background noise, so I want to make sure that whoever has ability to talk is on mute if we could. With that, I'm going to go ahead and get started on the presentation, make sure we have everything going. And so one of the things that has been happening over the last couple decades is the explosion of IT-enabled components in the operating environment. When you look at TCP/IP and the evolution of technology as it occurred from, let's say, the late 80s to today, there's been just a rapid explosion of TCP/IP and internet-connected things. Some of the things that are connected on the network today maybe were not totally designed for industrial applications. But if you look at some of the Gartner data and some of the things that have been occurring over time, there's a huge exponential explosion in the number of devices in industrial operations and process control. And that's kind of what I'm going to talk about. I've been in the industry for a long time. I've done automation projects on everything from cat crackers to pipelines to small operating fields to large operating fields. And one of the things that they have in common, when you look at, I'll give you an example, a cat cracker back in the mid-'80s probably had a couple hundred to a couple thousand sensors depending on the size of the unit. Today, the same plant will have over 100,000 interconnected devices. And access to that information and the connectivity to that information is really critical. And as we move forward, I'm a firm believer that we're going to have even more connected devices, and we're seeing that already in the different uses for those devices. Moving to that, one of the things that's getting blurry today, and it's definitely blurry for me as we migrate forward, is the connection between operating technology and information technology. 10 years ago, this was totally unheard of. The IT guys kind of maintained their lanes, the OT guys maintained their lanes, and the paths shall never cross. That's not the case anymore. Those paths are actively crossing, and those lanes are getting blurred. When you look at whether it's a pipeline or a measurement field or an operating environment that we're using today, measurement and control typically went to SCADA, and that's all it went. It didn't really leave the control system, stayed locally. All the telemetry information stayed locally with the operating environment. But that information now is getting bridged in real time or near real time with the ERP systems for daily production reports that are going to the IRS or local states for DPR reporting. It's going to a account management system for billing and invoicing automatically of clients. All that is being commingled together in an environment where the data is just actively exploding into multiple ways. Thus, the convergence of the networks and the complexity of the networks has had to increase over time. So as we look at a fairly clean network 10 years ago, and we're going to go into a little more detail about that and how to properly outline your IIoT environment and future-proof it, you got to understand the mindset is shifting where you have to have the interconnection of data, both from an IT standpoint and an operational standpoint. And that's kind of where we're looking at today. If you look back at, say, the early 90s to the mid-90s, it was all proprietary systems, proprietary architectures, proprietary networks, proprietary protocols. A lot of them are serial. Not much use of different layers. Everything usually functioned in a layer 2 base. There wasn't a lot of complexity. Today, what we're seeing is a very complicated, geographically distributed network with a variety of interconnected devices. Everything from mobile iPads in an industrial environment to iPhones to push-to-talk technology to CCTV to just a variety of different things that are now being layered on top of the technology. In the past, you could not layer those things into an existing network. Those things were typically, the operations guys would put in a network for their purpose, for telemetry, and it remained that way. So leveraging that investment and future-proofing that investment never really occurred because those camps were never really talking. And if somebody went to one of the operations managers and said, hey, can I have access to my email when I'm rolling around in the field or when I'm in the plant? Can I look at logs to see how? The answer was quickly said no. And a lot of it was just mistrust on how the network was deployed or the capability of the existing systems to be able to allow that much data. Most of the systems back then ran 120 to 2 megs. That was about it. Today, they're still running that because the telemetry data is pretty small. But when you talk to customers today, they want more. And they really, at this point, they really don't know what they want, but they know they want to do more. They're being asked to leverage the existing infrastructure for a lot of things. And taking that investment that they're putting in and using it across the network, which winds up being true Internet of Things or true industrial Internet of Things. And when you look at the documentation around industrial Internet, IIoT 4.0 for commerce or industry, one of the things that comes in common across those is leveraging existing infrastructure to do more. Not necessarily mimicking existing infrastructure to do more. So when you look at how you're going to deploy a future-proof network, some of the things you need to consider really is that it can come out of the box and start working. You don't really want to focus on a system that takes 2 or 3 network engineers a couple of days or a couple of weeks to figure out. You want to work with a system that out of the box just functions, just works. In order to increase the value proposition, you need to have the ability to have devices that work both in a layer 2 and a layer 3 environment. The reason for that, it simplifies the installation. When you start looking at having to have a whole different architecture for layer 2 and a different architecture for layer 3, one, it increases the complexity of the network, but it also adds inherent cost to the installation. So minimizing that installed cost, simplifying the installation, not only for the workers of today, but for tomorrow, really adds enhanced value to the deployment. It making it less complex really does improve the efficiency of it. Eliminating pieces of equipment that tend to be redundant in a more robust, more future-proof architecture is a lot easier to do when you're looking at the right architecture. As you're looking at defining what you're going to do, the key thing is that whatever you're doing supports true peer-to-peer architecture, and it gives you no single point of failure. In more traditional networks, the technology for routing and meshing is typically maintained in a controller. One of the things that you want to look at is a system that's fully autonomous, self-healing, that doesn't rely on pre-configured network routes or network mesh nodes in order for it to work. Because if that main controller or that main pipe breaks, then you lose those segments. So autonomy and self-healing of the device is really important. If you're going to be doing mobility or even operator rounds, having a connected employee that's monitoring a plant or a process unit, having a make before break connection is really important. Traditional Wi-Fi products cannot manage multiple connections. They have to actually disconnect and reconnect as you move through a site. You need to have an architecture that allows you to maintain that connectivity concurrently as you're walking through a facility. This does a lot of things for you because it improves the connection with the employee. You can actually do performance monitoring of the employee and actually monitor where the employee is at in the event of an incident when you have that kind of architecture. That also enables a lot of things. Electronic permitting, the ability to do operator rounds, because even in today's technology, you're probably not going to put sensors in every device that you have around a facility. You're still going to rely on operators walking around or taking physical measurements of certain things like site classes or tank levels or temperatures on rotating equipment. Those kind of things are really important. to take, but you may want to capture them if you're doing some kind of performance modeling or that kind of thing, so that it enables that AI or those neural net algorithms to actually fine tune and calibrate with that spot information as well as the telemetry data. So that's really, as you evolve and you look at implementing the network of the future, looking at what you want to do today and what you want to do when you grow up 10 years from now or 15 years from now. What are the potential impacts on your overall network? Because you know they're going to grow. As you look at things that can be added, some of the sites are actually adding mobile assets to the network, so that, for example, if you have a production field sitting out in the middle of West Texas or North Dakota or Abu Dhabi or wherever, and as you're driving around those fields, you lose cellular connection, you lose network connections. When you deploy a network correctly and you look at the architecture of that network, the ability for that employee to drive through the field, maintain telephone connectivity, maintain connectivity with their email and information is really important. So that is kind of fundamental in looking at industrial internet for the future and what we're going to be doing with it in the future. When I look at why you want to do something like this, especially in today's crude oil and RBOB market, where crude oil is trading at $5 a barrel, gasoline prices are at almost a record low. I saw this morning RBOB was trading at 60 cents. The ability to be more efficient with what you have is really critical. Digitization and new technology incorporation are really good, but choosing the right technology for your platform is probably the most important thing you can do. You need to make sure that you balance the two, because if you're looking at gaining efficiency and you're looking at gaining flexibility, you need to look at a flexible architecture that provides that. And one of the things that we really pride ourselves in doing is working with our clients to ensure we enable that as they move forward through that design selection criteria. Because flexibility and efficiency are probably the two things. Whether you're running a petrochemical plant, an ice cream plant, or a production field, those are the key things. I'll give you a really rudimentary example. I've done some work with these guys in the past. They make some of the best ice cream in the world. But one of the things you're looking at is they have over 800 recipes for different ice creams. But for French vanilla, they have 32 different recipes. And the reason for that is because the people in El Paso like more vanilla than the people in Atlanta in their French vanilla ice cream. So they know that as the demographics of the market. So when you're building a flexible and scalable system, you need to be looking at what does that mean? That means reducing the transition time between products, having the information so that when you're running a batch process, you can reduce those transition times and eliminate some of that waste. If you reduce the transition time in an ice cream plant by even 30 minutes, you're looking at about 10,000 gallons of ice cream. If you're looking at a polymer plant where you're making high density polyethylene and you can reduce that by an hour, that's 10,000 pounds of high density polyethylene that goes into the scrap market that no longer have to. If you're in a production field and you're looking at how the field is operating and you're not telemetry and you have a pumper driving around taking that information, if that information is not recorded in real time, it may not get recorded till the next day when the guy comes back. And that pump could have failed an hour after he left, and you would have never known it because the guy had to drive for another 8 hours to get to the field. So implementing some of that automation improves the data quality, improves the visibility, and improves the efficiency of the field overall. So when you're looking at those things, you gotta look at the why of what you want to do it and how you want to do it as you implement. All this leads to increased uptime, less waste, and at the end of the day, it leads to a more efficient operation, which translates to money. It translates to performance at the cash register. It translates to revenue for the stockholders and the investors. And that's really what industrial internet is all about, to improve your global competitiveness in what you're doing. If you can take a system, implement it with zero downtime, and maximize your investment, that's really the name of the game: improve financial performance. I'm going to give you a fundamental example here of a production field. This could be a chemical plant. It could be a loading and unloading facility. But one of the things that we're looking at for this particular example is, how do we take a production field with roughly 700 wells, a tank battery spread out over 100 square kilometers or so, and how do you create a cohesive network within that? The existing issue was there's no fiber or DSL in the office. The network keeps dropping out. Wind in the area keeps knocking out the antennas and moving them around. Customers wanted to run real-time intelligence and asset management. They wanted to do well monitoring, real-time well log diagnostics, understand the surface and the pump data, look at historical information in near real time or real time. And so this is kind of where it started. So one of the things you got to look at is you need to shift the architecture and look at the philosophy that you want to deploy going forward. So in this particular case, the implementation of a mesh network was the logical thing to do. Implementing a pole infrastructure throughout where the Rajant breadcrumbs were deployed, looking at enclosures that were suitable for the field, the distance, and looking at how you were going to do the wells. Originally, it started with about 300 wells and a few support sites and tanks to make the whole thing work. Originally, it went for telemetry only. Then the customer wanted to add video, facility management, access control, timekeeping, and other things that were added. The particular site has evolved over the years. It's sitting at about 200 square miles currently today, over 600 well paths and sites that are being monitored. The ability to have a full mesh coverage throughout the entire facility. The ability to control and monitor, as well as have access to other information within the site, have become critical for the operator. And it's still growing. It's not going to stop there. We'll continue to grow at the site. The ability to expand the network becomes really important at this point. When you start looking at what you can do with an architecture like this is where it comes critical. I'm going to rest here and talk quite a bit around this particular slide, because the real examples of implementing a true Internet of Things technology is implementing a network that can be used and leveraged across multiple boundaries. That being said, a lot of times people will start with a production field or a plant to do X. That X can be monitoring your wells. That X can be personnel tracking. That X can be adding iPads or tablets for rounds. that's usually the entry point, and people tend to leave it there. What I'm asking is take a look at where you're at today and what you want to do long term with your facility and your site, and look at what is occurring with your competition and what different people are doing. Real-time analytics is key. Doing modeling and assessment of not only fixed, rotating, reciprocal equipment, jack pumps, lift pumps, all that information can be made available. But once you implement that architecture, you can use it for a whole host of things. There are drones that can fly a field and take a predetermined path and actually collect temperature data from set pieces of equipment, can collect vapor and do vapor monitoring for leak detection, can do a whole host of other things, LiDAR surveys, if you have a topology that changes on a regular basis, push-to-talk technology. We're seeing a shift in traditional push-to-talk architecture into this environment so that they can leverage the existing investment with a lower cost, license-free architecture. Self-healing and diagnostics around rotating equipment, ability to change the configuration on how you operate based on actual information is happening. Probably the coolest thing that I've seen in the last couple of years is augmented reality for not only training, but for maintenance, using explosion-proof C1D2 glasses in a plant. The mechanic can walk around the facility, look at a piece of equipment, select it, look at an exploded view of that piece of equipment, look at the rotating components, look at the bearings and all the pieces associated with it, and actually be able to order from a pick list what items they're going to need to do the repair. All this is done wirelessly. All this is done through the plant infrastructure network, as well as if somebody wants to know where the mechanic is at, you can actually see where the mechanic is at in the event there's an incident that occurs in the plant or those kind of things. So there's a lot of enrichment that you can do with something that started out as, okay, I want to implement iPads and routes within my plant. Then you can add all these other things that are value add that improve the efficiency of the operation without creating additional costs around the architecture. The other really interesting thing that is occurring is operator training. Operator training or plant personnel training, both from a safety standpoint as well as an actual hands-on how do you operate a facility, has become really the next generation tool. As new plants are built, plants are modified, operator training is becoming very dynamic and very realistic. It's almost like playing a video game, but actually walking through a plant and being able to diagnose it. So there's a couple of companies that are doing really cool stuff with this. They're making three-dimensional models of the plants using their 3D CAD drawings. And then when they get to the construction of the plant, they implement a mesh or a wireless network so that the people that are actually going to operate the plant can actually be walking around comparing the things that they learned in the model to actual production things that they're seeing in the plant. Getting a use to the actual facility, comparing what the model did versus what the plant looks like, looking at equipment. And now when they're walking around, they can augment the reality with a virtual, the levels increasing, their steam clouds here, and make it look and feel like they're walking around a true production site. there's a couple chemical plants that are looking at that technology to evolve to get to what they call a safer, faster operator, so that instead of doing on-the-job training for a year or two, compressing that into 5 or 6 months because of the dual approach that they're doing. The technology is really evolving around the whole concept of training and rounds and those kind of things. Excuse me. The other thing that's occurring around safety is the implementation of autonomous robots, not only to fly a production field and capture data. One of our guys is working with 2 construction sites, and they're going to be implementing autonomous drones for the construction phase of the plants. One is an LNG plant, the other one's a petrochemical plant. And what they want to do is do daily flyovers to look at where the materials shifted and where the growth in the sites is happening, and be able to compare their project schedule to actual production in real time. Okay, I was supposed to have this vessel stacked on this date. Oh yeah, there it is. It's up. And so it's the evolution of autonomous technology for different things is evolving to a level, and people are finding uses for it that I know I would have never envisioned. There's an operator in South Dakota that's actually using drones in their operation to look and do site surveys of insulators and valves for emission tracking. There's all sorts of stuff like that occurring. Autonomous robots are actually being used for tank inspections as well. So when you first open up a tank for maintenance, it used to be that you would send in a person in a full hazmat suit, breathing air, to do the monitoring emissions and testing and do the first pass photograph survey. Well, instead of doing that, you put a small robot in there and let the robot do all the sensing of that information in real time, bring that data back, and enable the safety of the employees prior to them getting in there without having to expose any individuals to any activities or anything that occur in the plant. So I'm going to start closing down and recapping kind of what we talked about, because I think we've talked about a lot of things. So I'm going to take the next 10 minutes to talk about kind of what we've said and what we've done in helping you plan. Talk a little bit about the next step and where things need to go, and then open it up for question and answers, and we'll have Judy take care of that. In summary, when you look at IIoT 4.0 and the explosion of sensor technology for the next plants and the next generation of plants, and even for your existing assets, one of the things you want to look at is efficiency. How do you do more with less? If you're in a production field, it's all about lifting costs. What is the best way to maximize your lifting costs? Granted, in a $5 a barrel world, it's very challenging, but right now that's because there's no demand. I truly believe that when the demand increases, WTI will be back in the $25 range, hopefully by the summer's end. But one of the things you do, let's say you're at $25 a barrel and you're out in West Texas, your lifting cost is really critical, and optimizing the lifting cost is really important. It doesn't matter whether you're in Abu Dhabi, Oman, or offshore Brazil. That is the key: reducing your lifting costs, reducing your transition costs, and reducing your transfer costs from an FPSO to a tanker or to a barge. All those things are really where it's at. looking at ways to optimize your installation so that the cost to deliver the material to the transfer point is optimized. And you have to look at it a way that you're going to be doing it with less, not more people. As we look at oil and gas in the future and even oil and gas in the past, a typical production field 20 years ago might have had 500 people. Today, that same production field might have 150 people. Tomorrow might have 100. But you got to look at, as we're evolving, the whole idea around automation and sensor technology is really about doing more with less. And how do you accomplish these tasks as you move forward? And I firmly believe that enabling an architecture for communication in whatever environment you're in really helps facilitate that. We're doing a whole variety of projects with a bunch of different folks, and it really is about that. Probably the most interesting project that we have going on right now is the loading and unloading operation for tankers and vessels, and increasing the flexibility of that and adding CCTV and other surveillance components to ensure not only compliance with local regulatory requirements, but efficiency and safety of the crews and monitoring the whole transloading operation. I think you got to look at the scope of what you're doing in a different way, not just what you're going to be implementing today, but how can you exploit it for future endeavors. The other thing we got to look at is architecturally, how to reduce the number of pieces of equipment in what you're doing. Because it's really important to simplify your network as you go forward. Some of the technology that we've done over the last few years, we've done it in kind of a kludgy way because there was no one architecture that met everything. So you had to put a layer 2 switch, you had to put routing, you had to do this, and then you had to do a bunch of weird IP4 configurations and all that kind of stuff to make it all work together. Some of the vendors actually didn't help. They didn't really understand not only the application, but how to deploy it in the environment. So we run across clients that are IP bound because their operations has grown so far that now they're segmenting different pieces so they can increase IP ranges and those kind of things. What we try to do is really future-proof your architecture. We can run both in IPv4, IPv6. We can do MAC level addressing, all that stuff to simplify the architecture. And when you start looking at what you have today, I challenge you to go back after this call and look at all the redundant devices that you have currently deployed to get that telemetry data securely, reliably back home. And you're going to see a lot of things put in place that make the complexity of the architecture a lot more, but also cost you a lot more to maintain over time. And you're kind of rigid in what you can do with what you have. So I challenge you to take a look at what you're doing, take a look at doing things maybe a little bit different in the future, and really embrace the explosion of information that's occurring. Because you never know when somebody's going to ask you to run a new report, automate something differently, or I want to add 300 cameras to my operating field so I can monitor when people are driving around because we had a fatality. Things change and things evolve rather quickly. With that, we have about 20 minutes. Have some time for a Q&A if Judy can take care of that. And then we'll do a wrap up in 5 minutes, short to the end.
Okay, so now that you have a sense of IIoT 4.0 and how it works, you probably have questions about how you can use it to make your own operation smarter and safer. So if you haven't already sent your questions, you can do it now. Just click on the Ask a Question area of the screen, type your question, and submit it, and we will get to you as soon as we can. To get started, though, Al, can you give a little bit more of an explanation about peer-to-peer versus point-to-point?
Yeah, so when you're looking at, the way our architecture is designed is there is no one fixed connection. The system automatically finds nodes within the network. It doesn't require a fixed point-to-point configuration. In traditional systems, the sites are programmed to go from point A to point B to point C, point C to point D. In our architecture, the kinetic mesh environment that we deploy, the systems find other nodes within the network and they route automatically. Each node becomes an autonomous, self-healing peer within the network. They're all equal. The mission of each node, and as we say it, and one of my sales engineer, the first time he said it, I actually laughed, but he said, in our world, every packet matters. So, and every packet does matter because we want to deliver each packet as quickly and efficiently as possible. So dynamic routing through that peer network is really important. If we lose a device, the systems around that device. In a point-to-point, if you lose that device, you lose communication. Everything fails. In our peer-to-peer network, they're all talking to each other. One breadcrumb can have 5 or 6 or 8 or 20 different active connections. If you remember what I talked about, we have this philosophy of make before break. So each node maintains multiple connections at the same time so that if one fails, it can reroute around it and it becomes a more stable, more reliable, more robust network. The other thing that people have a tough time grasping is that in our architecture, the more breadcrumbs you add, the more stable the network becomes, where it's very different to other technologies, because in other technologies that you deploy, the more infrastructure that you add, the more unstable it becomes. So that's kind of the difference. And if the individual wants to have more discussion around the whole peer-to-peer versus point-to-point, we can kind of take that offline. That can be really a whole hour discussion just around that.
Okay, thanks, Al. Another of our listeners wants to know if you can give a couple of more examples about how IIoT 4.0 is being applied offshore.
That is, so there's a lot of applications that is being used at. We just finished a deployment, actually in Corpus Christi, I think. One of our guys did it about a month or two ago. And it was around the ability of tankers to be able to talk to each other during lightering and offloading procedures, and the ability, in the event they have an oil spill, how to respond to it and communicate more effectively with platforms and other vessels around them. The mesh network out in the open water becomes really resilient and allows every vessel to talk and transmit data at a lot higher bandwidth, higher speed. That's one way. Personnel tracking is another. Seeing CCTV and infrared monitoring of equipment. Looking at intrusion and building parameters around facilities. If you're within a Coast Guard jurisdiction, that's really important. Looking at what's coming in and out of the facility, looking for devices. So implementing CCTV and those kind of things around a barge or a tanker or loading and loading operations, especially during weekend high traffic situations, becomes really important. Right now there is no high traffic in most of the places because most of these parks are closed. But when we get back to real business, that'll come to play. Just a variety of applications like that. We're working on a project right now for an FPSO where we're doing a lot of the design work for the dormitory, for the staff, and employee tracking, We're looking at surveillance across the entire vessel, not only on the vessel, but off the vessel, and making that happen. Everything except for the power generation facility, particularly on this vessel. There's quite a bit of stuff that can be done with those types of architectures offshore. Right now, we're actually in a better position than we were a year ago because we have ATEX Zone 0, ATEX Zone 1 device that we can deploy in drilling operations and offshore platforms that enable that to occur a little bit better than we did maybe a year ago. So, and we can give you more examples when we respond to the questions.
Okay, so can you talk a little bit more now then about what some of the other technologies are that are being deployed on Rajant networks?
I think I've covered a lot of them. We're looking at everything from putting a VLAN in to do access to email and corporate information through a Radius server, to push-to-talk technology, to just a variety of. Really, I haven't run across too many things that we can't do. It's kind of interesting because when you start talking to customers about this, and you ask them, you want to build a network for what you want to do today, but you want to look at the potential for tomorrow. And building a network that architects simple and elegant is really what you want to look at. And when you start opening it up to that type of questioning, it cleans it up a little bit better too. So we're basically just a pipe that provides the data infrastructure across the network. We have yet to run across anything from an application standpoint that the pipe really can't handle at this point. Now, if you wanted to do 1,000 4K cameras or something like that in a production, then we'd have to figure out how to re-architect it. But at this point, it's really the simplicity of putting that together.
Okay, you talked a bit about the real-time analytics. Can you give some examples of how you quantify that? So some quantifiable examples of how the real-time analytics are being put to use.
So an example would be if you're doing steam flooding or steam injection in a production field, bringing that data back in a high speed rate, couple cycles a second, and bringing that data back helps the production engineer understand the dynamics of the production field and understand how the crude oil in the steam is flowing through the caverns, to understand what the proper injection rate is within that cavern. In a fracking operation where they're doing downhole fracking of a piece of equipment, bringing all that data back to a centralized area to understand the right level of sand, the right level of mixture, the pressure of the pumps, and all that information as they're doing the fracking helps optimize the fracking. Understanding that the sand is going in at the right rate, the water sand mixture is correct. All those things apply in real time. There's a lot of things that people are doing with AI in the production field, taking that information to the cloud, looking at performance curves on rod pumps to ensure that the lifting stroke is correct, and bringing all that data back to understand, okay, this pump lifting stroke on this particular formation is occurring at this rate. The same exact pump at another field for the different formation. Why is it performing differently? Why does it have more torque on the head? Why? And all that analysis can occur, and the comparison can be occurring at the same time, where a lot of the companies haven't had ability to do that in the past. So there's no, if you talk to a data scientist within a lot of these companies, if they can get access to the data in a reliable manner, they find all sorts of uses for it. And then the problem comes in that they find all sorts of uses for the data that they have. So they come back and say, hey, can I get this? Or can I get this? Or can I get this? And then that starts making that infrastructure even more critical.
Okay, and how is the network segmentation done?
The network segmentation can be accomplished in a variety of ways. The simplest way is to create different mesh networks. If you get to a certain size in a mesh architecture, you might want to create different mesh networks. This particular question, I'm going to address in a lot of detail next week when we talk about cybersecurity and implementing a cybersecurity philosophy in a mesh network. But fundamentally, you can set up multiple VLANs. Each VLAN has its own routing and configuration architecture assigned to it, and its own security. You can set up one VLAN to be an AP that broadcasts wirelessly. You can set up that particular AP to do whitelisting or blacklisting or authenticate to a radius server. All that technology is built within the breadcrumb. You don't have to go procure something else. It's part of the architecture. And when I talk about simplifying that layer 2, layer 3 environment, it's really about doing more with one piece of equipment. Really, a piece of equipment that's designed for that type of application for IIoT, not for an AP, not for a building, not for a construction site, really for an industrial application. So the way I look at our equipment designed for industrial application, outdoor harsh environments, not necessarily indoor type environments. So when we look at a deployment, really it's the elegance of being able to segment all those pieces into secure, reliable pipes. And each pipe has its own purpose. Each pipe has its own autonomy. Each pipe has its own ability to communicate the data that you're assigning for it. And then you can also implement, there's a whole host of smart devices that are built around explosion proof and the ability to talk in a Class 1 Division 1, Class 1 Division 2, ATEX Zone 1 or 2 environment with smart tablets, smartphones, those kind of things that implement that type of technology. So it's really around segmentation, and we'll get it. I plan on, in my closeout, is talking more about what we're going to talk about next week and deploying a secure cybersecurity strategy. I have about 2 minutes left before we do a wrap up. We can take 1 or 2 more questions, Judy, and then we'll respond to the rest via email.
Okay. Somebody's interested to know one of the military projects that you've worked on and criticality and reliability of the system.
I personally don't do military projects. We have another group that does that, and it's handled by another individual. A lot of the technology that we do use is sometimes first deployed in the military, especially our encryption algorithms and some of the things we do there. And the security around our mesh network, a lot of it is, a good piece of it is developed for the military. The kinetic mesh architecture is heavily used by the military. Specific types of deployments in the military, I'm not the right guy to ask. It's not something that I do. I'm on the oil and gas energy side, so on that side of the world, yeah, I can tell you what we're doing. On the military side, unfortunately, that's not my cup of tea.
Okay, well, if we're going to give you the time to do your final wrap up, I guess that's all the time we have for the questions during the live event. If you have questions and you haven't asked them, you can send them in right now. We'll still be able to capture them and you can get answers. And as a reminder, the presentation is going to be available online on demand within a week of the live event. It will be on upstreamonline.com. And as a registrant, you will get a reminder email. So I will let you wrap up, Al, and then we'll let people know about next week's webinar.
Okay, thank you. So as a close, I just, I'm available if you have any specific follow-up questions. Like Judy said, all the questions will be answered, I would say within a day or two. They'll get, every attendee or every registrant will get an email pertaining to that, and we'll go from there. And if you have any specific questions, please don't hesitate to ask. And then next week, we'll be talking about cybersecurity implementation within an IIoT 4.0 environment, and look forward to your participation then. And with that, Diane, if you can close down the WebEx, and we'll go from there.